Yesterday we talked about chords, right? If two chords intersect, one part times the other equals one part times the other. Now I want to talk today, how do I find the length of a tangent and a secant now? All right, a tangent and a secant, and it is not the parts multiplied together anymore. All right, no proof for this. We're going to just get right to it. I'm going to tell you the theorem, how to find whether it be secants or tangents. Here you go, ready? And this is probably the most non-mathematical way I can show you. All right, whole times external. Can I just ask what goes through your mind when you hear the word external? Outside. Thank you. Outside. Yep. Outside. Equals whole times external. There you go. If you ever want to find a secant or a tangent length, I think of whole times external equals whole times external. Look at my first diagram up here. I just want to make sure we can apply this to a diagram before we put numbers to it. All right, so I got a question for somebody. 8. Sophia, do you remember what ABC was called? How many times does it hit the circle? Twice. Remember what it was called? It hit twice? Secant, right? And then, so is ADE, right? Not off the hook yet. Sophia, can you give me one whole secant length? Give me one whole name of a secant up there. Either one, because there's two of them. Okay, so everyone ready? I would do AC whole, ready? Whole times its external part. And Spence just told us that's the part on the outside. So whole AC times, what's its external part? Name the external part. 11? Inside or is that inside or outside? That's inside the circle, right? I want the part on the outside of the circle. AB. Everyone see that? Whole secant times the part on the outside, external. AB is the same as, now somebody give me the other whole secant length. Name the other whole secant. 7? AE times the external part, which would be what in that case? 9? AD. There you go. So that's how I would work this formula. Whole times this external equals whole times external. Now go over to my second diagram now. Ready? Go over the second. Can we do it for the second diagram? And watch what happens when we involve a tangent now. Okay, watch what happens when we involve a tangent. 5, give me the whole, not here, right? One job. 2, give me the whole secant length.
DB.
DB, everyone ready? DB. Now give me the external part. DB times 10. CB, good. Now watch what happens when we involve a tangent. Name the whole tangent for me. Name the whole tangent. 7. AB. And now name its external part. 12. There you go. So when we do whole times external for a tangent, it's the same value. Because a tangent is always on the outside. All right, good. Questions, comments, concerns? Before we put this to use today? Tangents and secants only. All right, here we go. Whole. Now look, here's the part that's going to really annoy you. You're in this mindset right now from yesterday that you want to do 5 times 10 equals 4 times x. Because you're thinking about chords from yesterday, right? Part times part. Not anymore. Whole times external. Come on now. Whole times external. Don't do the segments times each other. All right, give me one whole length. 13. Charlie, give me one whole secant length. 15. Good. 15 times its external part. 3. Spence? 5. All right, how do you express how long the other secant is? The other whole secant is how long? 8.
4 plus x.
Thank you. Not 4x. 4 plus x. Times, what's the external part? 8 again, Sophia. 4. There you go. Okay, make sure you separate the chords from yesterday and the secants and tangents from today. And then you guys can go ahead, and I don't need to hold your hand here. Take a look at the directions on top, too. If your answer's not a whole number, round it to the nearest tenth. When you're ready, let me know. 4, when you're ready. You all right?
I'm a little bit behind.
This guy. Let me know when you get there. Taking over for Abbott today.
X equals 14.75.
Did I say 100th?
X equals 14.8.
There you go. Good save. Good save. All right, next up. Now you got a secant and a tangent. Secant and a tangent. Give me the whole tangent, please. Whole length of the tangent. 13, 11 times external. 4. Come on now. 2. Now go to the tangent. What is the whole and external both of the tangent there? 13. Y and Y. Yep. 22 equals y squared, and I think you guys know where to go from there. Round to the nearest tenth again. Nearest tenth, 8. Sophia on fire.
4.7.
Got it. We feeling all right? One more decent one before I knock your socks off. I don't like when he does that. All right, be careful. One whole secant here. Give me the length of one. You can do, I don't care which one you do, but give me the length of one whole secant. Go ahead. 1, Anna?
Y plus 10.
Y, okay, nice. You went the hardcore one. Everyone see how she got the 10. 7 plus 3. Combine your like terms. So that one over to the right, the whole secant length is y plus 10. Don't leave it as y plus 7 plus 3. Simplify it for me. Simplify it. Times, how about that external part of that one? Oh, 1 again. Anna, double up.
8 plus Y.
Whoa. I just
wait,
want
the external part.
Yeah.
Sorry.
7. Hopefully nobody heard you. How about the other whole secant? 13, Charlie. 8 plus y times its external part. You guys are good today. 13, Charlie. Double up again. 2 doubles in a row, Carrie. Did you see that? 8. Not as good as your 4 sneezes in a row, though. That was epic. I still remember that. 7y plus 70 equals 64 plus 8y. I don't think we need to round for this one, right? When you have the value of y, let me know. 5. Good talk. Good talk. 9. 6. All right, we're ready. I'm going to combine yesterday and today in this one problem here, number 4. Yesterday and today. All right, we've been doing whole times external. Let's first, don't write anything down. Let me do the wrong work up here. I want to show you why whole times external won't work. Everybody see the tangent? Agreed? Whole times external, y times y. Now look at the secant right here. Everyone see the secant? Watch here. Whole secant would be what? 4 plus x plus 6. What's already the problem? I'm going to write something with a y and an x in it. That's a no-go for us, right? So everyone see, I don't want to do whole times external first. That might not be the way to go. But All right, I can't do whole times external, but what else do I have in this diagram here? And I'll help you here. I have secants and tangents, but I also have, Spence, what are NM and PR? They're chords, and they intersect, don't they, Spence? All right, so yesterday we said if I have two chords that intersect, I can do segment times segment equals segment times segment. So let's start there, because that'll just give me one variable. 10, give me two segments from one of the chords.
Like the numbers?
Yeah, just pick a chord and give me the two segments that make it up.
4 and 3.2.
They come from two different chords, though. Pick one chord, Iris, and give me both their Go ahead. Go ahead. Sorry. 3.2 times 10. Now everyone look at the other chord, NM, and give me its two parts so I can multiply them from yesterday. 1, Anna, what are the other two parts from NM? I'm sorry. NM.
4 and X.
4 times X. Everyone all right where that's coming from and why I have to do that first? Because if I try to do whole times external, I got an X and a Y. All right, when you have the value of X, let's use it. 1, Anna, again. 2 double ups, 1 class. 8 equals X. Good. All right, everyone. Now, let's find Y. Now we can do whole times external. 7. We ready? Whoa, relax. I haven't even asked anything yet. We just found X is 8. Here, can you give me the whole secant length now? 18. Good. 6 plus 8 plus 4. 18 times what's the external part of that secant? 9. What's the external part? 6. And then what do we already know about the tangent? 6. What's the whole and external of the tangent? Y and Y. Whew. Nearest 10th, remember? 7, what do you got for me?
10.4.
10.4. Good work. Good work. All right, picking this up before I just slam your confidence to the ground and kill all your dreams here. Doesn't look like much, right? Whole tangent and a secant, whole times external, right? So let's do that first. Think about it. I'm going to ask somebody, what is the whole secant, ACD? How long is the whole secant? So combine your like terms. How long is the whole secant there, ACD? 6, how long is the whole secant? Good job, Nate. 2x plus 4 times, how about its external part? 1, Anna? X. And then let's go over the tangent now. Somebody tell me the whole and external of your tangent there. 5. Yep, good talk. 13, Charlie? 10, 10. All right, everyone good? All right, let's go. Distribute your X, right? Distribute the X. (2x squared plus 4x equals a 100. Oh boy, how about this? I haven't seen this. We do have an x squared and an x in the same equation. So probably thinking about factoring, right? But I can't do that unless what? Did it last night on homework too. Can't factor unless one side equals 0. So go ahead, let's get the 100 over. Here's the problem though. I have never had you guys factor anything that had a number out in front. It was always 1. It's always been 1 this year, right? It's always been 1. I've only asked you to factor number things with there's a 1 out in front. So we can't do what are numbers that multiply to 100 or 4 apart. That can't happen here. right? Because there's a 2 out in front. So what the heck do I do if there's a number other than 1? Grab your formula sheet. This is why you have them. Whether you can factor or you can't factor, you can always rely on quadratic formula, Nate. Yeah, everyone getting fired up now. We can always rely on the quadratic formula to solve this. All right, so here we go. X equals negative b. Need a little help though. 13, Charlie, you know what your a value is here? Just the numbers. We don't put variables in the quadratic formula, so just the numbers out in front. Here we go. 2, how about the b? 4, and how about the c? There you go. So that's what I'm going to plug in right now with you guys. So negative b, what are you going to have there? Negative 4 plus or minus. Please put these in parentheses, just like you'll put them in parentheses in your calculator. Ready? B squared, so watch, 4 squared. Notice I'm putting everything in parentheses when I plug it in. Minus, read your formula sheet, 4, a value is 2, c value negative 100. And it's all over, not just the radical, all over 2 times 2. All right, now what you can do, you're going to have to do it twice though, because look, plus or minus, so we're going to have to do this twice. In your calculator, get up your fraction template. On the top, negative 4 plus square root. Just please make sure anything we put in parentheses, you put in parentheses in your calculator. Do negative 4 plus all of that, and then negative 4 minus all of that, and get 2 answers out, rounded to the nearest tenth. Go ahead, and then we'll talk about those answers. Make sure you use the subtraction button when needed and the negative button when needed. Don't mix them up. Negative 4 and negative 100 should get the negative sign, and the subtraction should be outside and inside as well. So make sure you do the plus version and the minus version. Round it to the nearest tenth. Parentheses where needed. All right, I'm getting positive 6.1 for one of my answers to the nearest 10. And I'm getting negative 8.1 as my other answer. Got a problem with any of those? I'm not keeping both though. Right? We can't keep both. Why can't I keep both of them? Which one should I get rid of and why? 12, which one am I getting rid of?
Negative 8.
Why?
Because you can't have a negative line.
If I plug negative 8 point in for AC, that's not going to fly, right? So that's gone. So 6.1 is my only answer. All right, so if that ever happens, you know you're going to have to factor because you see an x squared and an x in the same equation, but there's a number, an a value that's not 1. We're getting out quadratic formula. and then I'm going to let you guys do 5 on your own. All right, I'm going to ask somebody what they got for the equation. All right, so take 5 on your own. Remember, whole times external, whole times external. Give me the equation you solved. What equation did you just build here? 10.
12.5 times 8,
Why 8?
because that's the outside.
Okay, I don't use 4.5. I use the external part. 12 minus 4.5, which is 8. Yep, equals.
X times X.
There you go. Everyone was good there? And what did we end up with our final here? There's no rounding directions. I don't think any were needed. 13, what do you have? 10, yep. All right, good deal. Before I let you, we use quadratic formula for a reason today because you probably may need it on your homework on a problem or two. Go ahead, get going, book or get the online version.